Alright, here we go. Tonight's video is pretty vocabulary intensive. There's 6 definitions that you're going to have to write down on that foldable that I gave you. And then we'll do a few examples that go after that. But we'll talk about the properties. We'll do a few examples and then we'll practice just a little bit. So the first property is the substitution property of equality, which says that if A equals B, then A can be substituted for B in any equation. And what that means is that if you have an expression, for example, 2x plus 4, and I tell you that x equals 8, then this is, if we're talking A and B here, this is A and this is B. So if x equals 8, then 8 can be substituted for x everywhere I see it. So I can just use that 8 and put it in place of the x because they are the same thing. So that's what the substitution property says. The distributive property, which we have talked about, here's the fancy math definition for the distributive property. We have talked about it. We did do distributive property, the hippity-hoppity mess. Says for all real numbers A, B, and C, A times the quantity B plus C equals AB plus AC. And then also the quantity B plus C times A equals BA plus CA. And we've practiced the distributive property, but what that is saying is that if I have 2 times x minus 3, I can do the distributive property by multiplying this times this and this times that. So 2 times x is 2x and 2 times 3 is 6. So I can just multiply what's outside by everything inside. The addition property of equality. For all real numbers A, B, and C, if A equals B, then A plus C equals B plus C. So they're just saying that if I have if I have 3 numbers and I know that A and B are the same, if A equals B, for example, like x equals 8, then I can add the same number to both sides. And so basically what that's saying is if I have an equation like x minus 4 equals 3. Well, A equals B, okay? And so I can add the same number to both sides and it doesn't change my equation. So what this addition property of equality says is that I can do this. I can do plus 4 over here and plus 4 over here. And as long as I do it on both sides, I have used the addition property of equality to get that x equals 7 to solve my equation. You might also see it written like this. They'll put the plus 4 here and the plus 4 here to show that 4 got added to both sides. That's the addition property of equality. I added 4 to both sides. I use and that's the property you use when you're solving a single step equation or an equation where you want to undo subtraction. The subtraction property of equality says for all real numbers A, B, and C, if A equals B, then A minus C equals B minus C. So it's just like the addition property, only it uses subtraction. So if you have an equation like x plus 1 equals 10, then you can use the subtraction property and you can subtract 1 from both sides, and it'll, as long as it happens on both sides, you're good. And just like with the addition property, sometimes you might see it written like this where they show that they did minus 1 and minus 1 on both sides. But just as long as it happens on both sides, you've used the subtraction property of equality, and that's why we have it, so we can solve equations and find out what x equals. Multiplication property of equality. For all real numbers A, B, and C, if A equals B, then AC equals BC. So this says I can multiply by the same number on both sides. So if I have something like A divided by 4 equals 3. In order to undo division, I have to do multiplication. And so if I multiply by 4 on both sides, it will take care of my problem, and so I can find out what A equals. But the multiplication property of equality says as long as I do the same thing on both sides, I'm not changing my equation. So these cancel, you end up with A equals 12. And so it occurs on both sides. Now for the division property of equality, it says for all real numbers A, B, and C where C is not equal to 0. And the reason why C cannot be 0 is because you can't divide by 0. So C has to be a number other than 0. So where C is not equal to 0, if A equals B, then A divided by C equals B divided by C. So this is the property that says I can divide by the same thing on both sides. So if you have a problem, 2A equals 16. It says that I can divide by 2 on both sides. And as long as I do the same thing on both sides, I don't change the equation. So that my answer ends up A equals 8. So these are just the properties that give me permission to do the things that I do whenever I solve equations. I can add a number to both sides, or subtract it, or multiply it, or divide it, depending on what's happening. As long as I always do the same thing to both sides, I'm using that property and it's okay. And so now let's just see some examples of these properties being used. So number 1 through 4, all we're going to do is just name the property that's being illustrated. What property do you see? So if you look at number 1, I have 14 plus 6t minus 14 is equal to negative 4 minus 14. Well, look at how that equation is written. What is occurring on both sides? What is the same on the left and on the right hand side of the equal sign? Well, what is the same is this minus 14, and since there's a minus 14 on each side, this is the subtraction property of equality. And that's because they subtracted the 14 on both sides. So it's the subtraction property of equality. Now do the same thing with number 2. I have 5 times 4/5 x equals 20 times 5. So what is the same on both sides of the equal sign? Well, this 5 times. I multiplied by 5 on both sides. So that means this is the multiplication property of equality. Now on number 3, you're not going to be able to look at what's the same, because the only thing that is the same is that 23 stays the same. But if you look, I have 2 times the quantity of 5x plus 12 equals 23. And then I suddenly have 5x times 2 plus 12 times 2 equals 23. Well, the only way for that to happen is for you to distribute this 2 to both of these, which makes this the distributive property. So I distributed my 2, that's the distributive property. And then number 4, 7t divided by 7 equals negative 21 divided by 7. Well, the thing that is the same is this divided by 7 on both sides. So this one is the division property of equality. And so that's what they look like when put into practice. And so now let's just use it one more time for one last example. We're going to simplify the equation. Well, it's technically been simplified for you. We're just going to go through each step and decide what property they use to get from one step to the next. So then you have your equation there. You have 5x minus 4 equals the quantity x plus 3 plus the quantity 2x minus 1. And in step 1, you magically have 5x minus 4 equals 3x plus 2. And so what we want to do is figure out, how did we get from the equation to step 1? What did they do? Well, what it looks like to me is that on the left-hand side, everything is the same, but on the right-hand side, I have less stuff. The reason I have less stuff is because they combined like terms. They put their x's together. X plus 2x makes 3x, and 3 plus negative 1 is 2. So they combined like terms. And I know that's not a property, but that is what they did, and that's how we're going to justify that that was the step that was taken. Now from step 1 to step 2, you now have 5x minus 4 minus 3x, and then 3x plus 2 minus 3x, and so it looks like I have a minus 3x on both sides of the equal sign. So that would be the subtraction property of equality. And I'm going to start abbreviating. Property of equality, PO. Now for step 3, now what I have is 2x minus 4 equals 2. Well, so we need to talk about what happened here. I don't see the same thing on both sides. I don't see a minus something or a plus something, or that I multiplied the same thing on both sides. I just suddenly have less stuff. And so what it looks like to me is that they took this 5x minus 3x to make a 2x, and then the minus 4. And then over here, these 3x's cancel each other out, leaving just the 2. So all they did here was just simplify or combined like terms. Whoops. And so now on step 4, I think something is missing from step 4. I think step 4 should say 2x minus 4 plus 4 equals 2 plus 4. That way, what's on both sides of the equation is that I have a plus 4 and a plus 4. Since I added 4 on both sides, this is the addition PO. This is the property of equality. And so then to get to step 5, these canceled, leaving 2x. 2 plus 4 is 6. So again, they simplified. Or combined like terms. I don't care which one you choose, but they're the same thing, and so you can use either verbiage. I don't care which one. Now in step 6, I have 2x divided by 2 equals 6 divided by 2, and so it appears that we are dividing by 2 on both sides, which would make this the division PO. And then finally, step 7, I have my answer, x equals 3. Well, that's because we simplified. We divided by 2. 6 divided by 2 gives me 3, and so this one is I just simply simplified. Here, they did not combine like terms. There weren't like terms to combine. All they did was divide and got the answer, and so that's where they just simplified. So it's where we finished solving, and that is the answer. So that's what it means by justify each step. Tell me what property was used. What did they do to get from the step above it to that step? What is it that they were doing? Okay, and so you just need to look at the steps, see what's happening. You will practice this along with the rest of what we have talked about this week tomorrow in class. I hope that you got all the equations written down. If not, just back up, pause, write them down, and then you'll have your foldable when you come to class tomorrow. Have a good rest of your evening.